All right, guys. So I decided to just give you the notes key here online, so you can look through this and hopefully make sense of it, and then use the majority of your time practicing them on your own. All right. So first of all, we're diving into exponential functions today. If I was in class talking to you, basically, I would really have a big deal about how x squared and 2 to the x power are not the same thing. So we got a quadratic and then we got an exponential. So obviously we have a base here of 2 and a base here of 3. And if you take a moment, you can just take one of the inputs here, 3. If you take 3, 2 to the third power is 8, right? But if we change that base to a 3, when we do 3 to the third power, we get 27. So what happens is these grow, dun, 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 drum roll, exponentially more if you increase the base. Same input, remember, but the base is getting bigger. One thing we want to notice is everything to the 0 power is 1. Okay, everything to the 0 power is 1. All right, so basically this is what they're going to look like. You can think of it as like a new parent function, but the base is the key to these. Okay, so when we look down here at kind of a key point here, we have to have a is greater than 0. The base has to be greater than 0. If you think about that a little bit, 0 to any power, we wouldn't have an exponential function. So it has to be greater than 0. We'll talk about that more. If we don't have any transformations to these, the domain is negative infinity to infinity, as shown up above here. That's not following an asymptote over here. Just be very careful. It's not following an asymptote. It's growing without bound is the way we say that. And the range would be 0 to infinity on these graphs, horizontal asymptote at y equals 0. They will look like this, but we will shift and move them around as the backside of these notes will show. We'll talk about the natural base E later. When I have time, I can tell you how cool it is. There's a lot of natural phenomena that show that. For right now, just for right now, you do need to know that E is approximately 2.7, and we'll talk about that in a moment. All right, so this walks you through some steps in graphing, and I'm hoping you guys can look at these notes and work together to make sense of the notes and then try to graph them on your own. But basically, before I show you anything down below here, find the new origin, just like we normally do, left, right, up, down. And then we graph the horizontal asymptote through the new origin. So what I mean by that, scrolling up here, is basically we're taking this origin as normal and we're going to shift it around. Well, here's the key. The pattern is the key. I don't know exactly how to get anything but this circle showing because I'm not good at this. But what I want you to know is that 0, 1 is one key point. 1, A, whatever the base is another key point, and -1, 1/8 is another point. Those are 3 key points we can get all in this little circle right there, and that's going to help us graph. All right, so moving along here, we're going to get our key points, and we're going to graph them. So take a moment to look at this. Might seem a little intense at first, but I will slow down here. What I do when I look at this here is realize, like we set up above, that we're going to shift this left 2, and we're going to have a vertical reflection. If we just scroll down to the bottom, or next example, we would talk about how that is actually going to be a shift up and down. When it's tied into the exponent, it's left right. So I have this right here, this base of 3 as like my parent exponential function. So what I like to do is to get my nice 3 points right off of that. 0, 1 as always, -1, 1/3, 1 and 3. And I'm going to do those 3 key points after I have my transformation. So I have a vertical reflection, shift left 2. I think you guys are going to be okay with this. So if you think about that, we're going left 2. There's my new origin. Here are my 3 key points. You can see them. And I've had that vertical reflection as always. Looking at my stats here, I do have a horizontal asymptote at y equals 0. And this is my exponential function graphed. Now, when I look at the coordinates, be very careful here. This word is coordinates of the key points. It's not the ones here. It's not relative to the new origin. It's relative to the actual origin. So this order pair that I'm trying to highlight right in the middle here is actually left 2, and down 1. That's this key point right here, which goes along with this key point relative to the origin. Okay, so I'm not going to take you exactly through this whole example here. You can see it. Hopefully it makes sense with a base of 2. Just know that I have, since it's tied in here to the left-right maneuver, it's going to be a horizontal reflection. So normally the graph would be going up like this. Hopefully you can see that, but it's horizontally reflected. We get our key points, and we do our transformations based off of that. Only thing I want to say about the bottom one here, same thing. We got right 3, down 2. Work with each other. Make sure you understand how those go. Oh, I didn't even put domain and range in there. Sorry about that. But right 3, down 2, and then we have this base. Okay, well, what is that base? Again, it's E, and we can write our key points like this, but that is about 2.7. So when you go from our new origin over 1, we're going up 2.7 there. Okay, and this is approximately up 1/3 there, 1 over 2.7. So try your best. It's worksheet day, and we will make sure you understand it completely tomorrow, hopefully when I'm back.